Hello everyone, welcome back to the channel. Today we are going to learn about quadratic function in a simple and fun way. Before we start, let me draw a table comparing between linear equation and quadratic equation. So on the left side, I have linear function. On the right side, I have my quadratic function. For linear function, it is also known as a straight line from our session earlier. The general equation, let me just write this thing down first. General equation for linear function, it is y equal to mx plus c. I can also write it as f of x right here, equal to mx plus c. However, for quadratic function, I do not have y equal to mx plus c. I have y equal to a x squared plus bx plus c. It can be also written as f of x equal to ax squared plus bx plus c. If I were to draw it out, what does it look like? For linear function, it will gonna look like a straight line. Let me just give you one example here. This can be used to represent my income in Ringgit Malaysia or in USD. And I have my time in months. For example, at particular month, at my 0 month, the moment I step in, my salary, it is 2,000 USD. After the first month, my salary increased to, let's say, 3,000. On my second month, I can say my salary increased to 4,000. So there we go. We have a linear function, or we can say it is just a straight line. It can be represented by y equal to mx plus c. Not sure if you guys remember this. M stands for my gradient. How how slope, right? It determines the slope of the line. So I'm just gonna see gradient here, right here. Right? This can be calculated by using y2 minus y1 divided by x2 or minus x1. For the C right here, I have my intercept, my y-intercept. Basically, it is just the point where the line cuts through my y-intercept. Sorry, my y-axis. So in this case, my y-intercept, it is 2,000. I will just write y-intercept. It's 2,000. So let's move on with the quadratic function. For quadratic function, it will not look like a straight line. It will look like it can be a U shape or it can be an N shape. U shape or N shape. Let me give you one simple example. Okay, let's say I have my height. All right, when you throw a ball above, when you throw a ball to the sky above, the height will increase with time. This is my time right here. We just put time in second. This is my height in meter. I can represent the height versus time graph as a quadratic function. when I throw it up, this is not a perfect. Let me just draw it one more time. Okay, there we go. This one looks much better. When I at time equal to 0, that is the moment when I throw my ball towards the sky. At time, let's say equal to 3 seconds, my ball reached the maximum point of, let's say, 9 meters. And then it comes back, it falls down back to the earth. Okay, so we can represent the height of the ball, okay, with using my quadratic function. 1 second, 2 second, 3 second, 4 second, and 5, 6 second. There we go. This is one of the use of quadratic function. So if you can see, as we can compare, I have my y equal to mx plus c and y equal to ax squared plus bx plus c. We call a, b, and c the coefficient of my quadratic function. A, it's used to determine whether the shape of the quadratic function looks concave up or concave down. If it is concave up, my A is positive. When it is concave down, which with this case right here, my A, it is negative. B, it is used to represent my shift towards the left or towards the right. Okay, shift to left or right. Last but not least, we have my C, which is my y-intercept. I will stop here for a moment, else it will be a lot to take. Next part, we will look at how do we plot it in the next video. All right, that is next part. See you guys. If you guys like it, please consider subscribing and liking my channel. See you. Bye bye.